Okay. Let's start this session. So we are in digital electronics, right? So we had been discussed about the basics of digital. We saw the number system and we have seen the applications of digital electronics, right? Where are we now? Now we are designing switches, right? Yes. So in the last session, we had been discussed about logic gates, right? Logic gates in the sense we might have seen, right? How our logic gates will look like. We saw some standard logic gates. See, don't think too much. Logic gates in the sense they are simply acting as a switch. That's all, right? நம்ம வீட்டில் யூஸ் பண்ணுற switch அவ்வளோதான், right? On off. அந்த on and offல we have some different mechanisms. Like நம்ம நிறைய switches வந்து டிசைன் பண்ணிருக்கு இல்லையா? First we design not gate. That is simply called gate. Next we design OR gate, AND gate, NAND gate, NOR gate, XOR gate, XNOR gate. And we saw how to design, and the NOR gate, NAND gate matum, they are simply called universal gates, right? Why they are called universal gate? Why? Because without having any other gates help, right? Matta எந்த கேட்ஸோட ஹெல்ப் இல்லாமல் entire circuit can be simply implemented only with the help of a set of NAND gate or only with the set of NOR gates. ஒரு நார் கேட்டை மட்டும் வச்சுட்டு நம்ம என்ன பண்ணிக்கலாம் அப்படின்னா மற்ற எல்லா கேட்ஸோட ஃபங்க்ஷன்ஸை we can derive at the same time. Just with the help of NAND gates we can bring out all possible outputs, right? மற்ற எல்லா கேட்ஸோட possible outputs we can bring it out, right? Fine. So that's why your NAND gate and NOR gates are simply called universal gate, right? Fine. And apart from that we saw two special gates. They are simply called XOR gate and XNOR gate, right? Yes. So let's go ahead from there, right? That is the point I think where we left, right? So we shall just start from there. Now we have to see இப்போ அந்த switches வந்து electrical circuits வந்து எப்படி இருக்கு அப்படிங்கறத நாம இப்போ செக் பண்ணி பார்க்க போறோம், right? At the same time I would like to show you the transistor equivalent circuit, right, of the diodes, right? Sorry, logic gates. ஒரு லாஜிக் கேட்ஸ் வந்து நம்ம லாஜிக் கேட்ஸோட ஃபங்க்ஷன்ஸை we can bring it out just with the help of transistors, right? By using transistor we can bring out those functions. We will see. At the same time we are also going to அது ஜென்ரலாக வந்து பேசிக்காக ஒரு எலக்ட்ரிக்கல் சர்க்யூட்ஸில் வந்து ஸ்விட்சிங் காம்பினேஷன்ஸ் வச்சு how to bring the same output logic. Actually this is very important, guys, because even in TRB and TNEB, especially in gate also, right, these type of model circuits nowadays often they have started taking the questions from this area, because it's letting you all to think, right? Just it is giving a small work to our brain, right? Let's see what happened, right? How to design the logic gates. Anyway, refreshing all these things once again, it's my responsibility, right? So let us take all logic gates once, right? So let me develop the truth table and let me show you the circuits, right, quickly, and then we will take these circuits. Let's design the various switches, right? So let us take one by one, right? So first we had been designed NOT gate, right? Yes, the first gate already that we have designed is called NOT gate. Let us take once again. First we had been discussed about NOT gate. How it was being represented, NOT gate was simply, right? So we are using only one pin from the input side. Yes, right? And just what we need to do, we have to keep a small bubble. That's all, right? So that is called NOT gate, right? Now if I'll give input at the, sorry, if your input is A, then not output of the NOT gate is simply going to be A bar. Such type of gate, right? நீங்க இன்புட்ல பாஸ் பண்ற வேல்யூ இன்வெர்ட் ஆயிட்டு அவுட்புட்ல வந்தது அப்படினா that is called NOT gate. Do you all agree with me? Yes. Now let us see its truth table. What we saw, so input is A, output is Y, right? Now input A in the sense either it might be 0 or it might be 1. There are two possibilities. If your input is 0, then output will become 1. If your input is 1, then output will become 0. Why? Why? Because this is called inverter, right? So your NOT gate can also be called inverter. Why it is called inverter? Why? Because output will going to be the invert of input. See there, I am giving 0 but I am getting 1. That is the inverted version of input. I am giving 1 but I am getting 0. So that is the inverted version of input. So that is called what? Inverter, right? So let us design this inverter, right, with a basic switching circuit, right? So let us see how to design this one with the help of basic switching circuit. For that I am just considering an electrical input from the input side, right? Guys listen, I'm just considering an voltage source here. Just we are going to consider an voltage source here, right? And this voltage source will going to be connected with some type of LED bulb, right? And this is the point where we are going to consider our switch, right? Let us see our switch is being function, right? Switch ku vandu nama name vandu A appdinu vechirukom, right? So let's see what happened. Whereas this is the point where we are going to receive our output voltage, and this is the point where we are going to pass our input voltage, right? Let's see at which point we are receiving the output, right? So bulb vandu eppa eriyudhu eppa off agudunu paakalama. Let's see on and off state of your bulb, right? So let us see, that is A, right? And your output is V0, or you can say LED turn on and turn off, right? So we can also take bulb is our output state. This is our output state, where let us consider bulb B, right? So let us just consider bulb. Let's see what happened. Now if I am putting A equal to 0, நீங்கள் ஏக்கு வந்து 0 போட்டிங்க அப்படின்னா it means this switch is open circuit, because A equal to 0 in the sense your switch is open circuit, right? Logically I am speaking, guys listen, already I have been told you in binary, if I am considering 0, it means it is representing the ground point in the sense electrically that is 0 voltage, right? If I am putting 1, it represents the, in transistor it is called VCC, right? That is common collector voltage, right? Whereas generally it is called V reference, that is our supply voltage. So what will be the conclusion here? If A is 0, it means this switch is open circuit, right? So we are not passing any supply through this switch. If your switch is open circuit, then what will happen? The supply that we are giving from here, that will be directly started flowing through the output. Do you all agree with me? Yes, you have to agree with me. Why? Because this line is open circuit. So whichever the things that we are giving here, that will be simply started flowing through the bulb, such that your bulb will on. Bulb will on state in the sense, usually in digital that is called 1. On state are usually called, that is called positive logic, right? There will be one more logic that is called a negative zone. I will talk about those things, so slowly understand the basics, right? So basically according to the positive logics of the gates, on state denotes 1, right? So similarly when I am putting 1 in the sense we are closing the switch, right? If you are closing the switch, it means see it 1 in the sense your gate is being triggered, right, by with the help of some external sources, right, such that the switch is going to be closed. If it is closed, carefully observe this one, from this supply if it is closed, then there will be a short circuit, immediate short. Then what will happen? If it is short circuit, then we all know current will always choose low impedance path. Yes or no? Yes. So once this line is short circuit, then the entire power will start diverting through this line. Because of this short circuit, it will started flowing like this, right? There is no power, right, that is flowing through your bulb. Bulb liya current flow agadu. Why? Because across the bulb there is a short circuit line. Current will always choose low impedance path. So because of this, entire current supplied by the source will started circulating through the short circuit line, such that your output or your bulb is going to be turn off state, or we can call it as 0. Now just compare the bulb, right, your bulb with our NOT gate switching, right? We know the truth table of NOT gate, right? Now where is the truth table of NOT gate? For 0 output is 1, for 0 output is 1, for 1 output is 0, for 1 output is 0. Yes, exactly, this is the equivalent circuit of the NOT gate. Clear? So electrically we are looking at these things, fine, right? So this is the point where we are going to consider our switch. Guys observe, ஒவ்வொரு விஷயத்தையும் கேர்ஃபுல்லாக நோட் பண்ணணும். இங்கே எனக்கு என்ன வந்திருக்குன்னா, if I will consider a switch, right, in across with your லோடுக்கு பேரலாக ஒரு switch வந்தது அப்படின்னா, then we can say output, right? So let me call it as output வந்து நம்ம ஜென்ரலாக y ன்னு வச்சிருக்கோமா? Yes. For our NOT gate, output y is going to be the inverted version of the input. ஸோ தி கன்க்ளூஷன் இஸ், இங்கே என்ன சொல்ல வரோம் அப்படின்னா, ஒரு ஸ்விட்ச் வந்து டயோடுக்கு பேரலாக இருந்தது அப்படின்னா, தட் ஸ்விட்ச் இஸ் காம்ப்ளிமெண்டட் வெர்ஷன் ஆஃப் தி இன்புட். தட் இஸ் இங்கே ஏ இருந்தது அப்படின்னா ஜஸ்ட் யூ ஹவ் டு கன்சிடர் தட் இஸ் கால்ட் இன்வெர்டட் வெர்ஷன், ரைட்? தட் இஸ் கால்ட் இன்வெர்டட் கேட், ரைட்? ஏதாச்சும் ஒரு ஸ்விட்ச் வந்து லோடுக்கு பேரலாக இருந்தால் தட் கேட் இஸ் கால்டு வாட்? தட் ஸ்விட்ச் இஸ் கால்டு இன்வெர்டட் ஸ்விட்ச். தட் இஸ் கால்டு நாட் கேட். கிளியர்? எஸ். ஸோ ஜஸ்ட் observe slowly, we will extend our discussion. Now second gate. Next we had been discussed about AND gate and OR gate. So let me rub this one, right? Let us take the second gate. Yeah. Shall we take AND gate and OR, right? It's our wish. Let's take AND gate, right? My mind is blowing with the AND. Right? How we are representing the universal representation of this AND gate, right? This is the representation. Exactly, right? If I'll pass two alphanumerical variables through this, output is going to be the product of input. So a dot b is going to be the output of AND gate, such that, right? So there are four possibilities. Let's take a, b and y, right? Let's continue. 0 0, there are four possibilities. 0 1, 1 0, 1 1, such that what happens in AND gate, we all know AND gate in the sense just it is the product, right? So what happened here? 0 into 0, that is 0, right? We know, right? Let's continue. 0 into 1, 0. 1 into 0, 0 only. 1 into 1, 1. Normal product, right? So that is the output of AND gate. We all know, because AND in the sense multiplication. We all know AND denotes multiplication. So it is called multiplier. AND is called what? Multiplier, right? Okay, fine. Next, what we are going to do, we have to bring out the same type of combinations with the help of electrical circuit. Can you please try it by yourself? Let's see what happened. For that, I am just considering a switch here. With this, let me consider one more switch. Now I'm going to connect it with our electrical bulb. Let's see what happened, right? So I'm just connecting it with the electrical bulb. Once wait a minute. Yeah, let's connect a proper bulb. Yes. Now once again, here I'm going to consider our supply. Yes. Yeah, let's see what happened now, right? Now once again, where is our input? This is going to be our input supply. Exactly. And let's name them switch A and switch B, and this is the point where we are going to receive our output. Now let's check whether your LED bulb will going to blow or not, right? So let us test it by just considering our input variables are switches A, B, and we should consider our bulb here, right? Let's see when this bulb will going to turn on and when it is going to be turn off, right? So in order to know that one, what we need to do, let's take if a variable let's select the variable possibilities, right? Various possibilities. Let's consider both are having 0 0. A ku 0, B ku 0 கொடுத்தீங்க அப்படினா, what do I mean? I am not triggering none of this gate. ரெண்டு கேட்டையுமே நீங்க ட்ரிகர் பண்ணல. 0 0 in the sense ground potential, so your gates are not being triggered by anyone. So the conclusion is, if I am giving 0 0, then both gates are going to be open circuit. If it is open circuit, is there any path to receive the bulb வந்து எரியறதுக்கு ஏதாச்சும் path இருக்கா? See, if you want to let your bulb to glow, it has to receive the power from the input side, but I am not creating any path for your bulb to glow, so still it is dark. What is the conclusion here? Since when we are putting 0 0, both the switches are open circuit, such that your output is disconnected from the input side, so your output is going to be 0 only. Your bulb is won't glow, so we can say that is called off state. Your bulb is, it is not turn on. Let's consider 0 1. It indicates 1 in the sense bulb B, that is switch B, is going to be closed, right? And switch A is what? It is open circuit, such that what is the conclusion here? One switch is closed, I am feeling very happy. What about this one? It is open circuit, na? So out of these two switches, one switch might be closed, but still one more switch is open circuit. Once again, output is disconnected from the input side, such that still your bulb won't be glow. So I can say output is 0 only. That is called off state. Let's continue 1 with the 0. Is there any possibility to turn on the bulb? No, I don't think, right? Why? Because you may close bulb switch A, because we are triggering switch A. But what about switch B? Still it is open circuit, na? So again, your output is off state only. Suppose if I am giving 1 1, let's see what happened. If both are 1 1, automatically both switches will be closed. Yeah, now your bulb is feeling happy, right? It started receiving power from the input side, such that slowly it will become dark, right? So finally we are going to turn on the bulb. Yeah, what type of logic it is? That is AND gate. So AND gate electrically, that is the electrical equivalent circuit of the AND gate. Do you agree with me? Yes. Let's start our journey with the next gate, right? So let me rub this one. Okay, I would like to conclude one more small thing, right? Wait a minute. See there, guys, listen. If your switches are connected in series, actually we are talking about AND gate only, na? So we are getting AND operation. AND operation meaning, AND operation means A and B are going to be multiplied. See there, அப்போ ப்ராடக்ட்டில் வரும்போது மீனிங் என்னன்னா, see there we are getting the operation of product only. இதோட ஆப்ரேஷன் தானே நீங்கள் அவுட்புட்டில் ரிசீவ் பண்ணிட்டு இருக்கீங்க. அப்படின்னா மீனிங் என்ன, இந்த ஆப்ரேஷன் உங்களுக்கு வேணும் அப்படின்னா, ஏவும் பியும் மல்டிபிள் ஆகணும் அப்படின்னா 2 switches have to be what, they has to be connected in series. So if you find any switches in series combination, you should multiply them. It means they are cascaded each other, right? So if you find any series connection of switches, right, you can just multiply them, right? Their output is going to be series switches, means they are in product. Series switches in the sense they are cascaded with each other such that they are in product, right? So both are open, both are closed, one is open, another one, something will happen. But if once they are connected in series, just you can multiply them. See that is the proof for this. இதை வச்சு தான் நான் இதை டிசைன் பண்ணேன். My operation is satisfied. It clearly denotes if I find any series switches, I can directly multiply them. You don't need to perform. நீங்க ஆபரேஷன்லாம் பண்ணி அதை அண்டா ஆரா செக் பண்ணி பார்க்க தேவையில்ல. ரெண்டு switch வந்து சீரியஸ் இருந்தா டைரக்டா நீங்க அதை மல்டிப்ளை பண்ணிக்கலாம்னு சொல்ல வரேன். Clear? Yes, conclusion is over. Let's take our journey, right? So let us consider few more people. So this is AND gate, right? So let's select OR gate. Let's see what happened, right? Yeah, for that I'm just rubbing this one, right? Sorry. I'm ready, sir. Yeah. Let's select next person. அடுத்து யாரு? OR gate, right? So let us discuss about OR gate. Yeah. So when we are discussing about OR means we are trying to perform addition. Exactly, that is correct, right? But how it is being represented? The universal representation of this gate. Yeah. And if I'll pass 2 input through it, it will just add. So your output of the gate is going to be A plus B. Yeah, let's perform the operation. In case of OR gate, right, we have to take 2 people A, B. Output is going to be Y, such that 0 0 0 1 1 0 1 1. Now what happened? See, if I'm both are 0 0, but what I had been told you, ஆர் கேட்டோட அவுட்புட்டில், ரைட், உங்களுக்கு அவுட்புட்டில் வேல்யூ வந்து 1 வரணும் அப்படின்னா இன்புட் சைடில் அட்லீஸ்ட் 1 பின் வேல்யூ ஷுட் பி ஐ. ஹை லோ அப்படின்னா மீனிங் என்ன? லோ மீன்ஸ் 0, ஹை மீன்ஸ் 1, ரைட்? அப்போ இன்புட் சைடில் இருக்க யூ கேன் கனெக்ட் thousands of pins here. See, don't think that only 2 pins can be connected with your OR gate. It is not mean like that. We are going up with the minimum variables. You can increase the number of variables from the input side. It will happen in future. I am going to increase the number of inputs, right? So here I am just considering 2 inputs. It does not mean that only 2 inputs can be connected with the gates. It does not mean like that, right? Fine. Let's continue our journey with this. Anyway, the conclusion is output is going to be high whenever at least, right, in order to let the output to become high, at least you have to consider one input pin as I. Input la edachu oru pin oda value 1 ah irundha output la 1 varum. If both are 0, output is going to be 0. Sari, see there at least one pin. ஒரு பின் 1 இருந்தாலும் அவுட்புட் 1, 1 பின் 1 இருந்தாலும் அவுட்புட் 1. See that ஒரு பின் 1 இருந்தாலே ஓகே, more than 1 okay, that is I'm feeling happy. You can happily let these things to happen, right? Yes, this is the output of OR gate, and we have to design this one, right? Let's see the electrical equivalent circuit, that is called a switching circuit, right? So let me design the switching circuit, right? Is it going good? I think board is visible to you all. If you have any problem, immediately make WhatsApp call, right? I'm here only. Let's take our equivalent circuit. What shall we do now? We have to perform OR operation. You should strike வந்திருக்கணும் மைண்டில். நம்ம என்ன பார்த்துருக்கோம், நமக்கு இப்போ OR ஆப்ரேஷன் வேணும். லாஸ்ட் கேஸில் 2 சுவிட்சை சீரியஸில் கனெக்ட் பண்ணும்போது மல்டிபிள் ஆகுது. அப்போ அடிஷன் வரணும்னா ஜஸ்ட் parallel connection. Yes, right? So you have to perform parallel operation now. Let me do parallel operation, right? Yes. Now let us see. So this is going to be our electrical equivalent switch. Once again, it is going to be connected with our electrical supply. Yeah, let us see. So this is going to be our output voltage V0. Where is our bulb? This is our LED bulb. Let's take, there are 2 people A and B, and let us consider our input voltage as Vn, and this is going to be our output voltage V0, right? And we are considering 2 bulbs here, right? So that is 2 switches. Shall we start our operation? Yes, let's see, right? Once again, I have to consider person A, switch B, and then we should consider bulb. Let's see what happened, right? So let us consider 0 0. If I am giving 0 0 for both of these people, what will happen? It means I am not triggering both of these guys, so they are simply standing. We are not closing because you did not apply any triggering pulse for me, right? அப்ப அவங்க ஓபன்ல தான் இருப்பாங்க. Then what will happen? If both are open circuit, automatically your output will become 0. Why? Your bulb won't be able to receive any power from the input side. ரெண்டு சுவிட்சுமே ஓபன்ல இருந்தா யார் வழியா நீங்க பவரை பாஸ் பண்ணுவீங்க? So output is bulb is turn off. Off state means positive logic, that is 0. Let's trigger any one of the switch. I am going to close the switch B. Guys, please notice this one. When I am closing this switch, now there is a path, right? A path will be created for your output such that, see there, your power is coming here, power is coming here, it is going, yeah, bulb is glow, right? If your bulb is turn on, exactly on state, output is going to be 1. Let's consider 1 and 0. 1 and 0 in the sense, this switch is going to be closed and this is open circuit such that your power will come here, it will go, yes. Bulb will glow, that is on state. Let's see 1 1. Happily we can let these things to happen. See there, both of these guys are going to be closed. So what happens? Power will come here, it will be split up, it will go, again they will group together such that your output will receive the power, bulb will turn on, right? So it will glow and the output state is on. Am I getting the same sequence? Yeah. So it is the electrical equivalent circuit. So what I have understood, whenever or a general circuit la, if two switches are connected in parallel, it means they are performing addition operation. If two switches are connected in series, they are performing what I can say, cascade, that is multiplication operation. Clear? Yes. Let's continue our journey with this, right? So let me rub this one, right? What I need to do, yeah. So let us select the next one. The next type of gate is NAND gate. Next one is NAND gate. So let me rub these things, right? You can just do it by yourself. Anyway, I'm doing, right? Let's see how to design NAND gate, right? That is electrical equivalent circuit of NAND gate. What we saw, actually already we had been discussed, right? NAND gate is the inverted version of AND gate. Yes. So if I will pass two input through the NAND gate such that output will become A dot B whole bar. Exactly, that is true, right? Now according to De Morgan's law, De Morgan's theorem, this statement can also be rewritten as A bar plus B bar. Exactly, that is true. Do you all agree with me? Yes, that is correct, right? Anyway, let's start our journey, right? So from here I can say, so I'm in need of A dot B whole bar, right? And we all know the truth table for this one. Anyway, bringing the truth table is my responsibility. Let me do it by myself first. So what I have to do, there are four possibilities: 0 0, 0 1, 1 0, 1 1. Just substitute. 0 into 0 will become 0. Whole bar will give you 1. 0 into 1 will be 0, whole bar will give you 1. 1 into 0 is 0, whole bar will give you 1. 1 into 1, 1, whole bar will give you, just you have to take invert for AND gate, right? Yes. So that is going to be the truth table of your NAND gate. We all know, right? But we are not targeting these things. Already we taught this, that is I taught these things already, right? So our target is electrical equivalent circuit. Let's see how to design the electrical equivalent circuit, right? So in order to design the electrical equivalent circuit, I'm just thinking and see, I understood one thing. I'm in need of A and B. எனக்கு என்ன தேவை அப்படின்னா ஏவும் பியும் மல்டிபிள் ஆகணும். இப்போதான் நம்ம கொஞ்ச நேரத்துக்கு முன்னாடி பார்த்தோம், cascade operation means two people has to be connected in series, then only they will be multiplied. ஏவும் பியும் மல்டிபிள் ஆகணும் அப்படின்னா A கெட்டிங் 2 கெட்டிங் சீரியஸ்ல கனெக்ட் பண்ணணும், ஏவையும் பியும் சீரியஸ்ல கனெக்ட் பண்ணணும். கனெக்ட் பண்ணியாச்சு. அடுத்து நம்ம என்ன பண்ணோம், the second operation that we need to perform here is whole bar we should take. நம்ம ஆல்ரெடி ஒரு விஷயம் பார்த்துருக்கோமே, எந்த இடத்துல நமக்கு பார் வரும், if your switch will be connected in across with your load, then it will be complemented version of the actual value. நம்ம நாட் கேட் டிசைன் பண்ணப்போ நான் சொன்னேன் இல்லையா, if a person will be connected in parallel with your load, automatically that is called inverter. So we need two people. First we should let them to multiply and then we should take whole bar. Did you got any logic now? Just apply it, you will get the answer, right? So let's see once again. Let us connect the LED bulb here. Yes, bulb is connected, right? And let us consider our electrical supply, right? Yes, that is also over now. What is our next target? Let's connect the switches, right? First of all, I am in need of A dot B. For that, I'm just connecting switch A with B such that A and B are going to be multiplied, and since they are connected in parallel to the bulb, so automatically complement will happen. Shall we check? Yes, let's cross check. Output is our bulb. Once again, there are four possibilities: 0 0 0 1 1 0 1 1. Exactly, that is true. What is the output, right, for this possibility, right? So the output of the function is going to be, let's see, 0 0 கொடுத்தீங்கன்னா என்னங்க நடக்கும்? It means whenever we are giving 0 0, one switch, sorry, both these switches are going to be open circuit. If they are open circuit, then see there, your power will, that is your supply, will come from the input side. We all know that is going to be the input, right? Now your supply will come here, it will go like this. Since both of these switches are open circuit, now automatically they will reach your output. They will force your bulb, push your bulb to glow. Yeah, happily your bulb will become bright now, right? Such that your output will be turn on. I can say that is called 1. According to the binary logic, that is 1. Similarly, if it is 0 1, guys listen, A is 0, so open circuit. B is 1, okay, so what? B is closed, but still A is open circuit. You cannot do anything here. Once again, your current is started flowing through the bulb, so bulb will glow, so bulb will turn on, such that it is going to be 1 only. 1 0, if I put 1 0, automatically what will happen? It might become 1, so I can close this one. What about this one? It is open circuit, I cannot do anything with that, so automatically your output is going to be on state only. Still your bulb is glowing, happily it will glow. Finally, I'm not feeling happy with this one, I would like to turn off the bulb, right? So I'm just triggering both of these gates. Then what will happen? Immediately when these two switches are turned on, there will be a short circuit. Current will choose always low impedance path. Whenever you are closing a short circuit line, automatically the entire current supplied by the source will start flowing through the short circuited line. So your bulb won't be glow, automatically it will be turn off. Your bulb will become off state. So that is called zero state. Do you all agree with me? Yes, right? So that is the correct statement. Yes, I got the equivalent circuit of, that is equivalent switching, right? Equivalent electrical circuit of whom? 1110, that is what? NAND gate. Yes, so this is the electrical equivalent circuit. Do you all agree with me? Switching circuit, right? Fine. Let's take the NOR gate. Let me rub this one. So let us select the NOR gate, right? Let's perform the same operation. Yeah. So next what we are going to do, we have to do the same thing for NOR. Can you please do it? Don't wait for me. I know you all have understand what I'm doing here, right? NOR gate. It is the inverted version of OR gate, such that just put a bubble here, that's enough. Pass A and a B variable through it. So output will become, it is the addition, right? A plus B whole bar. Just we should take bar for this, such that what happens? Let's see, A, B, output is Y, 0 0 0 1 1 0 1 1. Clear? Exactly, that is true. Now what will be the output? Let's see. As since we are performing NOR operation, anyway, 0 plus 0 0, 0 bar will give you 1. Exactly, that is Q. Whenever we are giving 0 1 to the OR gate, that will become 1. But if I take complement for this, that will become 0. 1 0 will give you 1 only, but 1 bar will become 0. If I give 1 1, OR gate will be enabled, output will become 1. But if I take bar, automatically that will also will become 0. So since it is the inverted version of OR gate only, na, so that is the actual output logic. Exactly, that is correct. I would like to get the electrical equivalent circuit. Shall you do it? Yes. Let's see. I hope you all are getting the idea now. A plus B, in the sense I should connect two switches in parallel. Do you all agree with me? But I have to take complement. Where will be connected? It will be connected in across with the load, right? So automatically, so just consider an electrical equivalent circuit. Yes, from the input side, let me connect it with the supply. Okay. And output side is going to be connected with the bulb. Okay, there will be no problem. Let's connect these switches here, right? So let us connect the switches like this. This is A and this is B. Since two switches are connected in parallel, so we can add them. and the resultant combo will be connected in parallel with the bulb, so automatically it will become A plus B whole bar. Do you all agree with me? Yes. So let's start our journey with this. We can try our level best. We have to try. Let's see. This is going to be our output. Yeah. Now we have to see when this LED bulb will going to glow, right? Let's see what happened. The various possibilities are A, B. Let us check the bulb. Right? Once again, there are 4 possibilities: 0, 0, 0, 1, 1, 0, 1, 1. Exactly, that is true. Now what will be the output? Let us write the output. See, output of the function is going to be, if I am giving 0, 0, what will be the output? Bulb output. If I am giving 0, 0, both these switches are going to be open circuit. It is open, this is also open. Can you receive the output? Yes, I can receive, because both are open circuit. So your supply is simply started flowing like this, and your bulb will glow such that output will going to be 1, or I can say on state. Correct. Let us consider the second state. 0, 1 in the sense A will be open circuit, B will be closed. See there, B will be closed in the sense short circuit. If you find any short circuit, automatically what will happen? The supplied power will started traveling through the short circuited line, and it is getting back to the source, such that your bulb won't glow, right? Your bulb won't glow. So we can let your output is what? Your bulb is going to be turn off. Yes. Similarly, when we are giving 1, 0, 1, 0 in the sense, see A is going to be closed, but B is open circuit. Once again, what will happen? Output is going to be 0. Why, sir? We are closing A. A is short circuit. Current will always choose low impedance path, right? If I will find any short circuit line, automatically the entire current delivered by the source, it started traveling through the short circuited line, such that you won't be able to let your bulb to glow. So, right? If your bulb is won't glow, then that is called off state. In digital, that is called 0. Let us consider 1, 1. When I am putting 1, 1, both switches are going to be what? Short circuit. If both are short circuit, automatically what will happen? Already one line short anale enakku prachana. Idhula rendu line short ana, I cannot receive any output, such that output is going to be off only. Am I correct? Yes. So this is the electrical equivalent circuit of your, what I can say, NOR gate. Clear? So let us take the X, that is XR and X NOR gates. So let us rub these things. Can you please do it by yourself? Because we should bring, right? Neenga try pannunga. I'm just giving that 2 things to you, right? Okay guys, now ipo ungalku ellame purinjiruchilla. One small task. Take XNOR and XR gate, try it by yourself, right? Try it, because in your examination they won't give general circuit. You will be tested with some different circuit. While solving the problems, I will let you know, right? Yes. So my request, please do these things for XR gate and XNOR gate by yourself and post it in the group. I will check whether it is correct or not, right? Anyway, I am just refreshing the truth table of XR gate and XNOR gate. What we saw for XR gate, just I am refreshing, right? I am not going to design electrical equivalent circuit. That's your responsibility, right? Okay. First of all, the representation of the XR gate. Yes, this is going to be the representation of the XR gate. What about the XNOR gate? This is going to be X NOR gate. Yeah, this is XR and this is XNOR, right? And such that we are going to provide 2 variables AB, and here also we are going to provide 2 variables AB, such that your output will become A, B, and this is going to be, let's see, and here it is going to be A, B, and this is going to be output, right? Now what I had been told you, in XR gate, output is going to be A exclusive of, that is exclusive OR with B, whereas its output is going to be A XNOR with that is B, and we all know its equivalent circuit can be, that is equivalent value, A bar B plus A B bar. Similarly, this one can be written as A bar B bar plus A into B. That's all. That is going to be the outputs, right? So let us consider, right? So let us rub these things. Let's continue. Now here the truth table is 0, 0, 0, 1, 1, 0, 1, 1, and here it is 0, 0, 0, 1, 1, 0, 1, 1. Now what will be the output? Shall we check? We all know. Anyway, let us refreshing this thing. Let us refresh. Inga 0 substitute pannunga. 0 bar will become 1. So 1 into 0 will be 0. Plus A is 0. 0 bar will become 1, but 1 into 0, 0. 0 plus 0 will give you 0 only. If you substitute 0, 1, 0 bar will be 1. So 1 into 1 will become 1. So 1 plus 0 dot 1 bar, that is also will become 0. So 1 plus 0 will give you 1. So next will become 1, next is going to be 0. You can just try it by yourself. Similarly, if you are trying here, 0 bar will become 1, 0 bar will become 1. So 1 plus 0 will give you 1. So 0 1, 0 bar will become 1 only, but 1 bar will become 0, automatically it will become, so inge now 0 into 1 will become 0 only. So 0 0, this is going to be 1. Clear? Yes. So these are all the logics that you need to remember in your mind, right? Yes. Okay, fine, right guys. I had been told you one more thing, right? So here, how many variables that we are considering? We are considering even number of variables, right? So even number of variables, a b, here also I am considering a b, right? So if you are considering even number of variables, I only told you, right, what we saw, XOR gate will be different from XNOR. If you are going up with the odd number of variables, then XOR XNOR will perform same operation. Please revise your notes once, right? Since we are considering even number of variables, if you are going with the odd number of variables, then your operations will become same, right? Don't forget, because you will be tested for worthless 1 mark questions in your exam. Okay, is it going good? Yeah, I think class is going good. Okay, fine. So I'm just letting you all just to spend some time, right, design the electrical equivalent circuit, because I had given the basic idea, right? My responsibility is over. Now your task is just to design the electrical equivalent circuit. Okay, fine. Now our next target is, we are going to do the same thing with the help of transistor, right? I know till we have not discussed about analog circuits, right? But hopefully we can do. That's not a big deal, right? Simply we can design. Just I am giving basics, with that we will continue, right? Let us see. First of all, we should consider transistor, right? So let me take NPN transistor. Guys, there are two type of transistors are available, right? One is called NPN transistor and another one is called PNP transistor, right? So anyway, I am going to consider NPN transistor only, right? And here in NPN transistor, see, this is called collector and this is called emitter and this is called base. Usually base is the controller for our transistor. I am just giving basics. Rest of the in detailed constructions and explanations, operations, everything we will see in analog electronics, right? Right now I don't want to waste my time, just understand. So there are three terminals for our transistor: collector, base and emitter. I am just considering NPN transistor. Negative layer, positive layer, negative layer. Don't think too much, just understand. It denotes the direction of the current such that, see there, through the base your current will enter, through the collector your current will enter, and the emitter will collect the current such that, see there, if I apply KCL at this junction, right, base current is entering into the transistor, collector current is entering into the transistor, emitter current is going outside, such that emitter current will be the combination of collector current plus base current. Clear? Right? Fine. Next, what we need to understand, when this transistor will going to turn on, it's very simple. It is same as our normal gate. Now if SCR பாத்தீங்க அப்படினா, SCR எப்பங்க turn on ஆகும்? SCR எப்ப turn on ஆகும்? SCR turn on ஆகணும் அப்படினா ரெண்டு கண்டிஷன் நம்ம பார்த்திருப்போம், right? In power electronic circuits at all, usually we are designing the circuits with the help of SCR only. அப்ப SCR வச்சு நம்ம டிசைன் பண்ணிருக்கும்போது, we saw if you want to turn on the SCR, then two conditions are mandatory. First one, anode voltage should become greater than the level of cathode voltage, but that is not the sufficient condition. I should apply what? Gate pulse. Gate pulse நீங்க apply பண்ணல அப்படினா your SCR won't be turn on. Getting back, similarly, you can apply. இப்ப collector வழியா நீங்க supply கொடுத்துட்டு current கொடுத்துட்டீங்க அப்படினா transistor turn on ஆகாது. It is waiting for base, right? Once you give the base is acting as a pulse here, right? That is like gate pulse, right? If you are giving base current, automatically transistor will turn on. So the operation of the transistor will be controlled by current, right? So it will be controlled by current. So we will see automatically there will be some name for these things at all. I'm just giving introduction. Slowly we will see all those things in analog electronics, right? So your NPN transistor will be controlled by base current. Clear? Yes. Fine. Next, what we are going to do, the conclusion is, there are two things. அப்போ நீங்கள் கேட் கரண்ட், இப்போ நம்ம என்ன பண்ணுறோம் அப்படின்னா, கேட்டுக்கு நீங்கள் சப்ளை கொடுத்தீங்க அப்படின்னா, திஸ் ஐ மீன் பேஸுக்கு நீங்கள் சப்ளை கொடுத்தீங்கன்னா, திஸ் டிரான்சிஸ்டர் வில் டர்ன் ஆன். If you are not giving any supply to the base, this transistor won't be turn on. First conclusion, this is over. Clear? அப்போ நீங்கள் இந்த transistor turn on பண்ணணும் அப்படின்னா, in digital it is called, we should consider two people, 0 and 1. 0 means we are not giving any supply to the base. 1 means we are giving supply to the base. If you are not giving supply to the base, transistor will be turned off. It will act as a open circuit. If you are giving 1, transistor will turn on. It will act as a short circuit, right? So 0 indicates, 0 means base current will become 0. Base current will become 0 such that transistor will be turned off, or I can say it will act as a open circuit. Now if I am giving 1, it indicates transistor will turn on, automatically your base current will become not equal to 0 such that transistor will turn on state, and we can call it as, that is called a short circuit. Clear? Yes, that's all. There are 2 things to consider. Those 2 things I had considered, right? Now let us perform the operation. Let me rub this one. Start பண்ணலாமா? Yes. First we have to design transistor equivalent circuit for NOT gate, right? Yes. அப்ப NOT gate க்கு வந்து நம்ம டிசைன் பண்ணோம் அப்படினா, just keep your attention here. See what I am doing here. Oh, please 1 second. Yeah, sorry. Yeah, this is VCC, common collector terminal, and this is the point where we are going to collect the output, and let me consider a variable A here. Shall we check now? Yes, this is called collector resistance or C, right? Now let us perform the operation. See what we are going to do, very simple, right? We have to consider 2 variables for A and we should check the output. Guys, listen. If A is 0, then transistor will turn off. It will be open circuit. If your transistor will be open circuit, then what happen? Automatically this VCC will come here and it will be reflected in the output side. Out of this VCC, some portion will drop here, rest of portion you can receive at the output side, right? So but you think you see there, A க்கு நீங்க 0 கொடுத்தீங்கன்னா transistor actually turn off. If it is turn off, then actually current flow இருக்காது, right? Clear ஆ சொல்லணும்னா current flow இருக்காது. This voltage will be reflected here because it is open circuit. In open circuit, current flow won't be there. If there is no current flow, then there is no voltage drop in this resistor. So இங்க நீங்க எவ்வளவு voltage கொடுக்குறீங்களோ, that voltage will be reflected in the output side. So output la neenga voltage receive பண்றீங்க அப்படினா, since VCC is called reference voltage, in digital that reference voltage is called 1. So output is going to be 1. When I am giving 1, இப்போ நீங்க 1 கொடுத்தீங்கன்னா transistor will turn on. If your transistor will turn on, it means there will be a short circuit. அப்ப இந்த இதோட equivalent circuit எப்படி இருக்கும் அப்படினா, second caseல, though there will be a resistor, transistor turn on in the sense it is acting as a short circuit. It will be a short circuit. If it is the short circuit, then clearly notice here I have 0 voltage, that is ground potential. This is the output point. This is the output point. Since this transistor is short circuit, so this short circuited voltage will be reflected here. What will happen? Here you may have VCC, but what's wrong with this? Out of this VCC, this total voltage will going to be dropped across the resistor only. Why? Because here I have 0 potential. Directly this 0 potential will be reflected at this point. 0 into anything will become 0 only except infinity. So your output is going to be 0 voltage. So I can say when the moment we are giving A is equal to 1, automatically output is going to be 0. Did you notice? This is the operation of inverter. So this is the transistor. We can also, this is how we are performing inverter circuit. That is, this is called inverter equivalent circuit, right? So with the help of transistor, we are designing the switches. Fine. Let us take the second circuit. AND gate and OR gate. Class is going good? Yes. So let us take AND gate. Let's continue our operation, right? So in order to design the AND gate, let's see AND gate na cascaded, right? So connection is cascade because AND is multiplication. Just now we saw, right? So apna meaning enna, we should consider 2 transistor. So let me consider 2 transistor. So we have to provide 2 inputs A, B, right? Once again, I have to consider collector resistance here. Yes, and this is going to be VCC, and here I am going to consider one more emitter resistance, and let me connect it with the ground. This is emitter resistance, and this is the point where we are going to receive the output. Let us check what happens now. Now of course this is going to be collector resistance RC, right? Now what I have to do, we have to develop the equivalent circuit, right? So let us develop the equivalent circuit. A, B, output is going to be Y, right? So let us perform the operation. When we are giving 0 0, guys listen, just observe, when I am giving 0 0, both the circuits are going to be open circuit. If both are open circuit, then what will happen? Still we have zero voltage here. Listen, that is ground potential. These transistors are open. அப்போ இங்கே யாருமே கிடையாது, இது வரைக்கும் இங்கே யாருமே கிடையாது. டேரெக்டாக இங்கே கிரவுண்ட் இருக்கு, இங்கே ஒரு டெர்மினல் இருக்கு, அவ்வளோதான். அப்போ இந்த ஜீரோ வோல்டேஜ் என்ன ஆகும்? ஆட்டோமேட்டிக்லி will be reflected. See, since both are open circuit, open circuitல current flow இருக்காது. அப்போ இந்த resistor will become useless resistor. So this zero voltage will be reflected such that output is going to be 0. Let's see 0 1. If I will get 0 1, useless. 0 means this transistor will be open circuit automatically. அப்போ இந்த transistor turn on ஆகும், but useless because it is open circuit na, இது openல இருக்கே. So அப்போ இது ஆன் ஆனாலும் still it is what? இது வரைக்கும் இதோட right, இது வரைக்கும் closedல இருக்கும், but இதுக்கு மேல எல்லாமே open. So again it is what? In open circuit current flow will be 0, so there is no drop, so this 0 voltage will be reflected such that output is again 0 only. கரண்ட் ஃப்ளோவே இருக்காதுங்க. கரண்ட் ஃப்ளோ இல்லைனா ரெசிஸ்டரில் ட்ராப்பே இருக்காது. அப்போ ரெசிஸ்டர் அங்கே இல்லாத மாதிரியே நீங்கள் கன்சிடர் பண்ணிக்கலாம். அதை அப்படியே ஷார்ட் பண்ணிட்டீங்கன்னா இங்கே என்ன வோல்டேஜ் இருக்கோ அதுதான் இங்கே ரிஃப்ளெக்ட் ஆகும்னு சொல்கிறேன், ரைட்? லெட்ஸ் சி 1 0. If I will consider 1 0, same scenario. 1, this gate will turn on transistor, but this transistor will turn off na. So same scenario, open circuit, once again current flow irukadu, you can remove this resistor, this 0 will be reflected. Finally 1 1. If I will give 1 1, yeah, I am feeling happy. Both these transistors will going to be turned on. Yes, there will be a short circuit such that the supply will come. It will reach the output. Yeah. So finally, output is going to be 1. Now this resistor will work. Why? Because current flow will be there. Na? This transistor will turn on. This transistor also will turn on. So your supply will happily flow through this circuit. Yeah. So output is going to be 1. So this is the equivalent circuit of the transistor, right? I hope things are clear to you all. Just to learn the basics, I'm not letting you to memorize anything here, right? Because I already told you in digital there are no things to memorize. Once you understand the logic, you can play with your equations. In your examinations, questions will be very easy questions. You can easily get 2 marks, right? Out of 2, 8 marks, aduna 8 marks ninga appade vaangilam. There are no plenty of work to your brain. Just you have to understand the basics. That's enough. This is AND gate. Let's see OR gate, right? So let me rub this one. Let us see OR gate. OR gate na meaning enna? We saw already, right? OR gate na 2 switches will be connected in parallel, right? I hope, right? Pananga babu, you please try it by yourself. Digital பொறுத்த வரைக்கும் once நீங்க புரிஞ்சிருச்சுனா நீங்களே போட ஆரம்பிச்சிருவீங்க எல்லாமே, right? There are no things to understand here. Basics. And it is easy, right? Fine. Let's see. எப்படி கனெக்ட் பண்ணலாம்? இங்கே ஒரு டிரான்சிஸ்டர் எடுத்துக்கலாமா? Let's see. Yeah, let me consider a transistor like this. இதுக்கு அப்படி இப்படி எடுத்துக்கலாமா? கொஞ்சம் அழகாக இருக்கும் பார்க்குறதுக்கு. Yes. Fine. Let me close them. Let me connect one more resistor here. Yeah. And this is the point where I am going to take the output, right? So let us take A and let us consider B, and this is going to be emitter resistor. Yes. Shall we perform the operation? Yes. Let's continue. Please do it. Now the thing is, here I have A, here I have B, and output is Y. Let's perform. There are 4 possibilities. Do it. 0 0 கொடுத்தீங்கன்னா என்ன வரும்? If you are giving 0 0, both these transistors are open circuit. If both are open circuit, automatically it is open circuit. அப்போ open circuitல current flow இருக்காது. current flow இல்லைனா இந்த ரெசிஸ்டர்ல drop ஆகாது. அப்போ இந்த 0 voltage அப்படியே அவுட்புட்டுக்கு வந்துடும். such that output is going to be 0. When we are turning on, there is transistor 1, B, AB. See, there A is 0, open circuit, but B is going to be turned on immediately. Once it is turned on, then supply will come here, it will go here, it will come here, it will reach. Yes, there will be a flow, right? நீங்க இந்த transistor on பண்ணீங்கன்னா your current will flow like this, it will go. அப்போ என்ன வரும்? there will be இங்க கொஞ்சம் drop வரும், இங்க கொஞ்சம் drop வரும், இங்க கண்டிப்பா output வரும். output கண்டிப்பா வரும். I am damn sure for that. So automatically you can receive output is going to be 1. 1 0 கொடுத்தீங்கன்னா it will same thing will happen. This transistor will turn on, this transistor will turn off. So feeling happy. Why? Because I had created one more way to reach output, right? So output is going to be 1. If both are 1 1, very happy, because now I have multiple paths to reach the output, right? So output is going to be 1. automatically, right? Fine. Now what is the conclusion here? This is the equivalent circuit of whom? OR gate. Yes, I am getting, right? So this is the equivalent circuit of the OR gate, right? So let us design the next one, right? அடுத்தது யாருங்க, we have to design NAND gate and NOR gate, right? So let us perform, right? So the next target is, let's take NAND gate, let's design. Yeah, let me rub this one. Let me consider NAND gate. NAND gate எங்க டிசைன் பண்ணலாம்? திங்க் பண்ணுங்க என்ன பண்ணலாம்? நான் யோசிக்கிறேன். நான் ஃபஸ்ட்டு எதாவது பண்ணி பார்க்குறேங்க. let us consider 2 டிரான்சிஸ்டரை ஒன்றா போட்டால் அது AND கேட்டு, ஏன்னா கேஸ்கடிங். NAND கேட் என்னன்னா AB ஹோல் பார் வரணும் இல்லையா, ரைட்? we shall think, let's see what happen. இது A, B, NPN டிரான்சிஸ்டர் only. பட் இப்போ நான் எமிட்டர் ரெசிஸ்டன்ஸ்லாம் எதுவும் கன்சிடர் பண்ணல, ரைட்? there is some spark in my mind, I'm just going in that flow. Let's see what happened. VCC, instead of taking output here, let me take the output here. Check பண்ணி பார்க்கலாமா? Don't draw, first let's check, because I too don't know. I'm just going in the flow that I'm getting in my mind. Let's perform. So there are 4 cases. Check பண்ணிடலாமா? 0 0 போடுங்க. 0 0, both are open circuit. Output automatically it will be reflected, output will become 1. Why? Because this is open circuit, this is open circuit. So what will happen? In open circuit, current flow won't be there, so there is no drop in the resistor, this voltage will be reflected, output will be 1. Agree with me? 0 1 கொடுங்க, same scenario. 0 1 கொடுத்தா this transistor will turn on, but this will open circuit, now still it will be continuous, it will be open circuit. In open circuit, current flow won't be there. If there is no current flow, then there is no voltage drop. If there is no voltage drop, then VCC will be reflected at this point, such that output is going to be 1 1 0. Same scenario, it will turn on, but it will turn off. Again VCC will be there, current flow won't be there because it is open circuit. In open circuit, current will be 0. If current will be 0, then there is no drop across the resistor. If there is no drop across the resistor, then this voltage will be reflected across the output. Yes, output is going to be what? 1. ரெண்டு பேருக்கு 1 1 கொடுங்க. If I will give 1 1, automatically both transistor will turn on, then there will be a short circuit. If it is short circuit, what will happen? This 0 voltage will slowly come back, right? It will be pulled up, right? So automatically it will be reflected in the output side, such that output is going to be 0. Yeah. What type of equivalent truth table is? That is the equivalent truth table of, that is NAND gate. For AND gate, 1 1 only we are getting output. Then for NAND gate, that is the inverted version of AND gate, na? That's all. We got the answer. Our next target is NOR gate. So let me design the NOR gate. I'm just rubbing this one. In your examination, I am repeating, you will be tested with some general circuits, right? Okay, in TRB, TNEB, you can expect the direct questions for time being, right? Anyway, understand the basics, right? That's enough. Don't memorize anything. Next, enna pannom? NOR gate தானே. Let's start. NOR gate என்ன பண்ணலாம்? OR gate na addition. Yes. அப்போ parallel circuit தானே. அதில் தப்பே கிடையாது, right? Yes. I understood one thing, that is going to be parallel. அப்போ நம்ம என்ன பண்ணலாம்? ஒரு common supply எடுத்துக்கலாம், RC or VCC, that is enough. Let us design a parallel circuit. Yeah. I don't have any doubt till now. Let's see. Let us close this one. அப்படியே ஸ்டார்ட் பண்ணிடலாம். எமிட்டர் ரெசிஸ்டன்ஸ்லாம் வேணாம். கண்டிப்பாக பண்ணலாமா? A, B, no problem. Shall I take the output at this port? Yes. செக் பண்ணி பார்க்கலாமா? Yes. Let us check. A, B, output is Y. There are 4 possibilities, 0 0, 0 1, 1 0, 1 1. Check பண்ணிடலாமா? Yes. Let's do it. வேல்யூ கொடுங்க. 0 0. ரெண்டுக்கு 0 கொடுத்தா both will open, output வரும். Why? Because இவங்க ரெண்டு பேரும் open ஆயிட்டா, it will come here. See there, if both are open circuit, current flow won't be there. If there is no current flow, then there is no voltage drop. If there is no voltage drop, then the supply voltage will be reflected here, such that output is going to be 1. Output is going to be 1. Exactly. 0 1 கொடுங்க. this is 0, this is going to be 1. Automatically it will be short circuit. If it is short circuit, then see there, here I have 0 voltage. It will come here, it will come here, it will go. Output will going to be 0. 1 0, this will turn on, this 0 will be pulled up, it will come here, it will go here, it will go here, such that output is going to be 0. 1 1, both are turn on, short circuit, 0 will be pulled up, right? What is this? This is the output of NOR gate. For OR gate except 0, for rest of all people we are getting 1. For NOR gate, that is the inverted version of OR gate, na? That's why we are getting these things. Clear? Now, once again, my request is, for rest of 2 gates, you have to design. That's your responsibility. So don't memorize anything, right? You have understood all these things, na? Just try it by yourself, okay? Take some free time, you can just try it, okay? So now, this is all about basics of the logic gates, right? This is all about basics of the logic gates, right? Now, let's try and bring the answer for various problems, right? And before that, I would like to conclude one more thing, right? So 1 second. Yeah. Let us consider inverter once. Just to take that inverter outside, already we had been discussed about inverter circuit. Inverter is nothing but our NOT gate only. The inverter அப்படிங்கிறது நம்ம NOT gate தான், right? Guys, till now we had not talked about analog electronics, na? Yes. See, there are no big things in between analog and digital. Already I had been told you. Here we are storing the data in digital. இதுக்கு அப்படியே பேக்ல யாரப்பனா அனலாக், அவ்வளவுதான். இதுக்கு அனலாக்னா ஒரு தனி சப்ஜெக்ட். நோ. அது நம்ம தான் அதுக்குள்ள இருக்க ப்ராப்பர்ட்டிஸ்லாம் டிஜிட்டலுக்குள்ள இருக்க ப்ராப்பர்ட்டிஸ் அனலைஸ் பண்ணோம்ல, அதுக்கு தான் நம்ம அங்கே போக போகிறோம், ரைட்? ஃபைன். எனிவே, அப்போ இந்த இன்வெர்டர் நம்ம என்ன பண்ண போனால், யூஸ்வலி we are trying to design 2 type of circuits, right? So with the help of inverter, usually we are designing vibrators, right? 2 type of vibrators we are going to discuss. One is called astable vibrator, right? And second we are going to discuss about bistable vibrator, right? Monostable also will be there. Regarding vibrators at all, we will discuss in analog electronics. We are not in analog, we are in digital. So here we are going to talk about only 2 vibrators. One is astable, another one is bistable vibrator, right? Now what is the difference? Astable in the sense, right? Astable now your circuit, right? Inverter with the feedback. If you find any NOT gate with the feedback, right? Odd number of NOT gate with the feedback will give you astable, right? So that is odd number of, right? Odd number of NOT gate plus feedback with the feedback, right, will be equivalent to astable multivibrator, whereas even number of NOT gate with the feedback, even number of NOT gate with the feedback will give you bistable multivibrator. Now let us discuss. Let me take astable multivibrator, right? So let us take astable. So அப்படினா meaning என்னங்க? It means astable na odd number, I said, right? So let me consider, for an example, let me consider 3 inverters like this. Clear? Let us consider. That is called astable. I said with the feedback, right? So there will be a feedback like this. Clear? Right? Such that this is going to be our output port, right? And through this we are giving the input, right? Like this. So feedback line that is going to be the output now, right? So just you have to give the feedback here. For an example, if the feedback line la vandu 0 varudhu vechukonga, this 0 will come here and it will go like this. It will come here, it will reach here. 0 உள்ள என்ட்ரானா என்ன வரும்? 0 அவுட்புட் வரும்போது again 1. கரெக்டா இது இன்வெர்ட்டர் தானே? 0 பாஸ் பண்ணினா 1 வரும், 1 பாஸ் பண்ணினா 0 வரும், 0 பாஸ் பண்ணினா 1 வரும். So see the inverted version, right? So astable, right? திரும்ப என்ன ஆகும் அப்படினா output will going to be, இப்போ 0 வந்தது 1 ஆ கன்வர்ட் ஆகும். Again 1 will come back here, right? So again 1 உள்ள என்டர் ஆகும், 0 கவுண்ட் ஆகும், 0 will become 1, 1 will become 0, such that this operation will be continuous, right? So that is called astable. See the operations we will discuss, right? In detailed explanations will be demonstrated, that will be given in analog electronics. Don't be panic, because that's quite interesting. We will see there, right? Because about regarding oscillator we are going to learn many beautiful things, right? ஒரு supply இல்லாம நம்ம oscillator run பண்ண போறோம். We will see about this beauty of this person in analog electronics, right? It's quite interesting, but not here. Fine. This is astable multivibrator. Let us discuss about bistable. Let me demonstrate here itself. Bistable in the sense we should consider 2 gates, right? So we should consider 2 gates. That is even number of gates, not 2, 2, 4, 6 like that, right? So if I will consider 2 gates with the feedback, that is called what? Bistable multivibrator. Right now just I am giving introduction only, just getting these things, right? Now from here you are requested to find out the total time period, right? For an example, இப்போ இங்கே என்ன சொல்லியிருப்பாங்க அப்படின்னா ரைட் in the given right inverter circuit, right, each and every NOT gate will take certain propagation delay. What do you mean by propagation delay? ஒரு சிக்னல் வந்து நீங்கள் இன்புட்டில் வந்து பாஸ் பண்ணுறீங்க. அப்படி பாஸ் பண்ண உடனே எவ்வளோ நேரத்துக்கு அப்புறம் அது அவுட்புட்டில் ரிசீவ் ஆகுது. In between the input and output there will be some delay. That is called, you know one thing, நான் இங்கே பேசிகிட்டு இருக்க டைமில் நீங்கள் அங்கே சிக்னலை என்னோட ஸ்பீச்சை வந்து ரிசீவ் பண்ணிட்டு இருக்க டைமும் சேம் கிடையாது. நான் இங்கேயே செக் பண்ணிட்டு இருக்கேன், ரைட், ஐ எம் ஹேவிங் மை மொபைல் ஹியர், ஐ எம் ஜஸ்ட் செக்கிங் இட், right. நான் இங்கே பேசினதுக்கப்புறம் after few seconds only I am receiving my voice here, right. So what will be the conclusion here? That is called propagation delay. So each and every gate will going to provide some certain propagation delay, right. These people will have propagation delay such that how many gates are there? 3 gates, right. So the total propagation delay, right, so the total delay, that is called the total clock time, right. So the total clock time of the circuit will going to be, it denotes, we should consider twice of, right. So twice of number of people, that is one complete cycle we should consider, right. So I am taking 2 here, that is 2 into n into TPD. Just do remember the formula, that's enough, right. So here that is the formula in order to obtain the total time period, whereas a TPD denotes the propagation delay of each and every gates, where n denotes the number of oscillators that we are considering here, right. So number of inverters, how many inverters are there? 3 inverters. So in your examinations you will be requested to find out the total time period, or that is clock time period, or the clock frequency, or propagation delay and the clock time period will be given. You are requested to identify the number of inverters, right. So just do remember this formula, that is very important. Anyway, most of the time you will be tested for frequency only. Since frequency is the reciprocal of time period, na, so it will be what? 1 upon 2 times of n into TPD. Clear? Guys, I am just giving introduction for the circuits. I am repeating, right? So we should discuss about these people with the extraordinary explanations in analog electronics. That is the last chapter of your analog electronics. There I will conclude with some reminder. Na etne sollirukadhu solliya naan nadutharan. Don't be panic, right? So just do remember. That's all. That is enough, right? I hope things are very clear to you all. You can this you will be tested for 1 more questions, right. Just to make a note of it. Bistable in the sense even number of gates plus feedback, right. Which type of vibrator it is, like odd number of gates plus feedback, what type of vibrator it is. That's why I am writing this statements here, right. So rest of things we will discuss there, okay. Just to make very clear notes, right. See, I thought of solving some problems here, so, but I told you that I am winding up the class at 7:30, right. So we are getting close, almost I have been crossed your time. So tomorrow we will continue, right. First we will solve some problems through the, that is from logic gates, and then we have to discuss about already you might be studied these things, min terms, max term, sum of product of sum, what is the relation between product of sum and the sum of products, right. And then we should discuss about K-maps, right. And then we have to design the beauty of K-map and what is the purpose of the K-map, that things at all we have to discuss. With that, phase 1 will be over, then immediately we will start the phase 2, right. So with this, let's wind up the class. If you have any other doubts, you can ask in the group, right. So thank you all.